There's a way to make contaminated water safe to drink using a single piece of metal you can hold in your palm. No filter cartridge, no pump, no electricity, no replacement parts, ever. Just one small piece of copper sitting in a container of dirty water. The bacteria die. The pathogens dissolve, the water comes out clean, and that same piece of metal, the exact same one, will stop every iron and steel tool you own from ever rusting again for the rest of your life. One metal. 2 problems solved. $3. Ancient Egyptians figured this out 5,000 years ago. But the global water filtration industry generates over $45 billion a year, according to Grandview Research's 2023 market analysis, selling you plastic cartridges that stop working in 60 days. A piece of copper that costs $3 and never wears out cannot be packaged, subscribed to, or reordered. That is not a coincidence. That is math. The question is not whether this works. Scientists at the University of Southampton confirmed it in peer-reviewed trials. The question is what you were doing when you set it up. Because there is one mistake almost everyone makes in the very first step, before the copper ever touches water. That wipes out most of the effect. We will get to that. The water filtration industry pulled in $45 billion globally in 2023. Let that sit for a moment. That is more money than the entire GDP of over 100 countries on Earth, spent every single year on plastic housings and carbon blocks and reverse osmosis membranes. The financial logic here is not complicated. You cannot charge a monthly subscription fee for something that costs $3 and never wears out. You cannot design a replacement cycle around a material that keeps working whether you check on it or not. The silence around copper in mainstream home preparedness is not an oversight. That silence is a business model. The ancient Egyptians did not have a word for bacteria. They did not need one. Around 3000 BCE, roughly 5,000 years before this video, they were storing water and wine in copper vessels. The Ebers Papyrus, one of the oldest surviving medical texts on Earth, written around 1550 BCE, specifically recommends copper for treating infected wounds and purifying water. They noticed that people who drank from copper containers got sick less often. They kept doing it. That knowledge moved. Ancient Indian Ayurvedic texts, going back at least 3,000 years, describe a daily practice called tamra jal, which translates directly as copper water, where you fill a copper pot overnight and drink from it in the morning. Not as a ritual, as medicine. Greek and Roman soldiers carried copper water flasks on military campaigns. Persian kings stored royal water in silver containers, but the water supplies for the armies below them ran through copper. The soldiers who drank from copper vessels came back from campaigns. The ones who drank from wooden casks often did not. Nobody wrote a paper about this. Nobody needed to. The results were visible. The scientific explanation arrived in 1893. A Swiss botanist named Carl Wilhelm von Nageli was studying how certain metals affected algae and single-celled organisms. He noticed something strange. Even at concentrations so diluted he could barely measure them, amounts too small to see, too small to taste, certain metals could still kill living cells. He called this the oligodynamic effect. The Greek root means small power. Think about what that means in physical terms. Imagine dropping a single grain of salt, not a teaspoon, just one grain, into a full bathtub of water. You cannot see it, you cannot taste it. But if you were a bacterium trying to survive in that bathtub, that one grain would be fatal. That is what happens when copper sits in water. The metal releases a very small number of copper ions. Think of ions as tiny invisible particles that separate from the surface of the metal the same way steam rises off a hot pot. The water is still water, but something invisible is moving through it. Those particles drift through the liquid. When a bacterium touches one, the ion punches a hole in the outer wall of the cell. The contents of the bacterium spill out. It dies. The copper keeps releasing ions. The ions keep working. A 2012 study published in the Journal of Health, Population and Nutrition tested this directly. Researchers filled copper vessels with water containing E. coli, Salmonella typhi, and Vibrio cholerae. Those are 3 of the most common bacteria responsible for waterborne illness worldwide. After 16 hours of contact with copper, none of the 3 were detectable. Not reduced to safe levels. Not reduced by 90%. Undetectable. 0. 16 hours is 1 overnight. You fill the vessel before you sleep. You drink from it when you wake up. That is the whole thing. Now here is where it gets even more useful. The same metal that kills bacteria in water also protects iron and steel from rust. Not because copper is magic, because of something very specific that happens when copper touches iron in the presence of moisture. Iron and copper are both metals, but they behave very differently when oxygen shows up. Think about 2 people at a dinner table. One of them will eat anything put in front of them. They cannot help it. That is the iron. The other barely touches their plate. That is the copper. When both metals are in contact inside a liquid, even just damp air, The iron reaches out and grabs the oxygen before the copper does. The iron takes the hit. The copper stays clean. We can use that tendency deliberately. If we get copper to physically deposit a thin layer onto the surface of an iron tool, the copper becomes a skin over the iron. Oxygen lands on the copper skin, finds nothing useful, and moves on. The iron underneath never sees the oxygen. The rust process has no starting point. It cannot begin. You have seen this mechanism your whole life without knowing what you were looking at. Old copper pennies left resting on an iron surface for a few weeks sometimes leave a faint pinkish-red stain on the iron. That is not oxidation. That is not rust. That is copper physically migrating from one surface to another. The iron pulled it there. The chemistry between the two metals is strong enough to move copper atoms across a gap. We are going to use that pull on purpose. We are going to guide it into a solution, control it, and coat every cutting edge and iron surface in your shed with a layer of copper that bonds and holds. There is one more thing about the way these two applications connect. The water use and the tool protection running off the same piece of metal, that changes how you think about what a preparedness material actually is. Here is what you need. I want to be honest with you about every number. You need a piece of copper. A standard half-inch copper pipe end cap at any hardware store costs about $2. A small sheet of copper the size of your open hand from the same store runs about $3 to $4. Either works for both applications. For water, the pipe cap is ideal. The curved inside gives more surface area in contact with the water, which means more ions moving through the liquid. For the tool coating, you need white vinegar. The ordinary kind from any grocery store, about $1 for a bottle large enough to last several months of use. You need table salt. The kind already sitting in your kitchen counts. You need a glass jar, a mason jar, an old pickle jar, or any glass container with a lid works. That is it. If you already own vinegar in a glass jar, and most people do, you're spending $2. If you need to buy everything, including the copper, you're spending about $4 total. That is the whole number. The mistake almost everyone makes happens before the copper ever touches water, not at the end. The first step. Hardware store copper pipe and sheet copper come coated with a thin manufacturing residue, a film left over from the industrial process that shaped and cut the metal. It sits on the surface the way a skin of grease sits on an unseasoned pan. If you place copper directly into your water container without removing that film, you get maybe 10% of the ion release you should be getting. People try this, notice nothing changes, and decide the whole thing is a myth. They are not wrong about what they experienced. They just skip the prep. The fix takes 15 minutes and costs nothing. Pour a small amount of white vinegar into a bowl, enough to cover your copper piece completely when you lay it flat. Set the copper in the vinegar. Leave it for 15 minutes. Watch the surface. It will change color as you wait, shifting from the dull brownish orange of hardware store copper to a cleaner, brighter salmon pink. That color change is the film coming off. The surface is now open. When the color is fully shifted, lift the copper out. Rinse it under clean water, dry it with a cloth. From this point forward, do not touch the clean surface with your bare hands. The oils from your skin will begin recoating it within minutes. Use a cloth or tongs to handle it. That is the one step nobody tells you. Everything else is straightforward. For water purification, take a glass, ceramic, or food-safe metal container, not plastic. Plastic can interact with the ion process in ways that reduce effectiveness, and certain plastics leach their own chemistry into the water over time. A simple ceramic pot, a glass pitcher, or a stainless steel jug all work well. Fill the container with your water. Gently lower the cleaned copper piece into the bottom. Cover the container with a cloth or a lid. Not airtight, just covered. Leave it for a minimum of 6 hours. 8 is better, overnight is ideal. In the morning, pour the water into a separate container and let it sit open to the air for about 5 minutes before drinking. That final step lets any faint metallic smell disperse the way the smell of hot coffee fades once it cools. The water is safe. The copper piece stays at the bottom of the original container, ready for the next fill. It does not wear out. It does not diminish. The same piece works every single time. For sizing, you do not need to measure or calculate anything here. When you look down into your filled container, you should be able to see the copper piece. If you can see it, there's enough surface area in contact with the water. A piece the size of a book of matches handles a container roughly the size of a large soup pot, about 2 liters of water. If you're filling a 5-gallon bucket, use a piece the size of your open palm. That visual check is all you need for rust protection. The step builds on the same cleaned copper piece. Start with a clean, dry tool. If the tool already carries rust, remove it first. For light surface rust, steel wool and a few minutes of scrubbing handles it. For heavy rust, submerge the tool in straight white vinegar for 2 to 4 hours. The acid in the vinegar dissolves rust the same way lemon juice dissolves the dark staining on a wooden cutting board. After soaking, scrub with a coarse cloth, rinse the tool under clean water and dry it completely. No moisture left anywhere on the surface. Then make the copper solution. In a glass jar, combine 1 part white vinegar and 1 part water. If you are picturing a standard drinking glass as your measuring unit, fill it halfway with vinegar and halfway with water. Add a small pinch of table salt, about half of what you would shake onto 1 egg. Drop your cleaned copper piece into this mixture. You will see small bubbles form on the surface of the copper within a minute or two. Those bubbles are the reaction beginning. Over the next hour, the solution will take on a faint greenish-blue tint. That color is called copper acetate forming in the liquid. Think of it as copper that has partially dissolved and is now suspended in the solution, ready to travel. Take your clean, dry tool, hold it over the jar, and submerge just the working end, the blade, the edge, the cutting surface, into the copper solution up to about the depth of your first knuckle. Hold it there for 20 seconds. Watch the submerged surface. It will shift slightly pink within those 20 seconds. That pink is copper physically depositing onto the iron surface. The iron is pulling the copper toward itself. The displacement reaction is happening in real time, in your hand visibly. Pull the tool out after 20 seconds. Do not rinse it. Set it on a clean cloth and let it air dry completely. Work in sections for larger tools. Submerge and dry the blade first, then the upper surface, then the back. When the entire tool has been treated, set it aside for a full 24 hours. The copper layer continues bonding to the iron surface as it cures, the way paint hardens long after it stops feeling wet. After 24 hours, wipe the tool with a light coat of mineral oil. The same oil sold for conditioning wooden cutting boards at any kitchen supply store, about $4 for a bottle that lasts years. The oil seals the copper layer. What you now have is an iron core, a copper skin, and an oil seal on top. Oxygen has 3 barriers to cross before it can reach the iron. It cannot. The rust process cannot begin because the iron cannot touch the air. That jar of copper solution stays active for months. 1 batch treats a full shed of hand tools. A dozen chisels, 3 draw knives, an axe head, a set of pliers, a handful of knives, a hoe, a cultivator. 1 afternoon, and every cutting edge you own is protected. Top up the vinegar if the solution loses its greenish tint. Drop in a fresh copper piece if the first one is mostly dissolved, which will take many months of heavy use. The solution does not expire. It does not need refrigeration. It sits on a shelf in its jar and waits. Picture the full picture. 1 copper piece handles water purification for 1 person. 2 pieces and a 5-gallon covered container handles a family of 4 for a week, filling every day. 3 jars of copper solution, 1 per major tool category, hand tools, garden tools, bladed tools, treats everything you own in a single weekend. No professional service, no sprays that expire in 8 months and cost $12 each, no replacement filters, no power, no bills, no infrastructure, no asking anyone's permission. There is one more thing that changes how you think about this combination, about using one material to solve both water safety and tool longevity at once, and it only surfaces when you step back far enough to see the shape of the whole thing. Here is the honest part. Copper water treatment works on biological threats, bacteria, many viruses, a number of waterborne parasites. A 2020 study published in Applied and Environmental Microbiology confirmed that copper surfaces inactivate SARS-CoV-2 within 4 hours of contact. The oligodynamic effect is broad and powerful against living organisms in water. It does not remove chemical contamination. If your water source is downstream from agriculture, fertilizers, herbicides, pesticide runoff, or downstream from any industrial activity, copper treatment alone is not sufficient for chemical safety. If your source is rainwater, a clean mountain stream, a well with no industrial neighbors, or any water that is biologically suspect but chemically clean, copper treatment covers you completely. If you have chemical concern as well, add a layer of activated carbon. Loose activated carbon available at any aquarium supply store, about $5 for enough to fill a small pot, can be packed into a cloth pouch and suspended above the copper piece in your container. The carbon handles the chemistry, the copper handles the biology. Together, they address nearly every real-world water safety scenario outside of heavy industrial contamination. For tools, the copper displacement coating works best on plain iron and low-carbon steel. The materials used in most traditional hand tools, garden tools, forged knives, and general workshop equipment. Stainless steel already has chromium built into its structure that resists rust, and the copper coating adds nothing to it. Aluminum is not iron, and the displacement chemistry does not apply. If you are not sure what your tool is made from, hold a magnet to it. If the magnet sticks firmly, it is almost certainly iron or carbon steel, and this treatment applies. If the magnet barely holds or slides right off, it is likely stainless or aluminum, and those tools do not need this process. There was a man found frozen in a glacier on the border of Austria and Italy in 1991. Scientists eventually established he had been there for approximately 5,300 years. They named him Otzi. When researchers examined what he carried, they found a copper-bladed axe, the only complete copper axe from that era ever recovered in the world. The blade showed evidence of deliberate maintenance. The edge had been resharpened repeatedly. The metal had been cared for over a long working life. Analysis of the contents of Ötzi's gut found evidence of water that had been treated or stored in contact with mineral materials. A man walking through the Alps 5 millennia ago, with no laboratory and no internet and no supply chain, had already worked out that copper kept his tools sharp and his water clean. He did not invent this. He inherited it. Someone before him passed it down, and someone before them. The knowledge moved through human generations the same way copper ions move through water, invisibly, continuously, and always arriving exactly where they are needed. The filtration cartridge companies arrived later, so did the rust prevention spray aisle, the rust inhibitor subscription services, the whole category of products built around a problem that costs $3 to solve permanently. They did not arrive because the old knowledge stopped working. Copper has not changed. The oligodynamic effect has not weakened. The iron displacement reaction is the same reaction it was 5,000 years ago. The only thing that changed is who decided you were better off not knowing. You know now, the copper piece costs $3, the vinegar is in your kitchen, the water container is already in your house, the tools that need protecting are already in your shed, everything you need is either already owned or one hardware store aisle away. The first night you fill a container before bed and drink from it in the morning, the thing you will notice most is not a taste or a smell or a color. You will notice nothing, because the bacteria will be gone, and that absence, that complete, quiet, invisible absence, is exactly what 5,000 years of human knowledge sounds like.